In this video, I'm going to show you the text analysis tools that are available in PCAs. The first tool that I'm going to show you is the automatic check for spelling errors. It will analyze all the text files in the input folder of the NLP form and correct automatically all the spelling mistakes. The files will not be overwritten by the tool, and a new folder will be created in the input folder, and the corrected versions of the processed file will be saved here. A log of the correction will also be created and will contain all the correction performed by the tool in each of the input files. Only English documents are supported. The second tool is an instrument to check for document similarities that uses Apache Lucene to compare text files in a folder and create a log file with the results. Apache Lucene is an information retrieval tool that retrieves all the most significant words in a document and builds an index of all the documents in the input folder. This tool uses its capabilities to compare the extracted features and tell if two documents are the same or contain parts that are equal. Let's run it on a set of files where I put two copies of two different files. You can see here the extracted feature list and the similarity score, that in this case is 100% since the documents are exact copies. Here are the extracted words, this is the file name as candidate, and this is the duplicate file name, and you can see the other duplicate file names. The next tool I'm going to talk about is the Summary Creator tool. This routine allows you to create a summary of an English document by extracting the most significant sentences in it. It evaluates the most important characteristics in the text and ranks the sentences in the document, then it returns the sentences with the highest scores. Another tool that we have integrated in PCAs is the Computerized Linguistic Analysis System by the University of Minnesota. The Computerized Linguistic Analysis System, or CLAS, is designed to evaluate written language output for syntactic complexity. So 3 approaches to measuring complexity have been implemented: Yngve, Fraser, and syntactic dependency len. You can read the tips files for more information about this tool. The next tool in the list allows you to build statistics on the verb voices in a text. It detects if a verb has been used in passive or active form. Let's run it on a sample file. As you can see from the output, it creates an Excel file with the field sentence ID, that is the sentence position in the text, the sentence, the recognized verb, the verbal voice, active or passive, and a number associated to it that is useful to create Excel charts. 0 represents the passive and 1 the active label. You can see that the sentences are repeated. That's because you may find 2 verbs in the same sentence, so the row is repeated here in the output. If you choose to import the output table as user table, you'll be able to create a pie chart of the distribution of the passive and active sentences in a text, or a line chart that represents all the sentences in the input document and their respective verbal voices. We can create now the pie chart. Here we have an example of that. We see the proportion of the active and passive forms. And we can also create the line chart. And here's the line chart. If you put the mouse over one of the points in the chart, you'll be able to see the corresponding sentence to the classification. 1, as I said before, is the active voice of the verb, and 0 is the passive. So here we see that the majority of the sentences are active form. You can also run a sentiment analysis tool based on the Stanford NLP that assigns a sentiment value to each sentence in a text. The values are very positive, positive, neutral, negative, and very negative, and to each of those values it corresponds a number from 4 to 0. Let's run it on a sample file. You can see here that the output we have the sentence index, again the sentence, the sentiment number, and the sentiment label. Neutral, positive, negative. To each one of the sentiment labels it corresponds a sentiment number. If you choose to import the output file as user table, you'll be able to create a pie chart of the sentiment distribution, a text, and a line chart that represents the sentiment in the document for each sentence. We can import that and create a pie chart. And here is the sentiment distribution in the text: blue for negative, green for positive, and red for neutral. We don't have any very negative sentence here in the text. And we can also create the line chart. And here it is. The sentiment goes up and then stays up. 1. On the x-axis of this chart we have the sentence index, and on the y-axis we have the sentiment number. If you put the cursor over one point of the chart, you'll be able to see the sentence corresponding to the sentiment. You can also choose to run an implementation of Word2Vec by deep learning4j that groups the words that have a similar meaning in an input text file. From the output of this tool, PCH creates a graph that you can visualize in Gephi. And the last tool that we added in PCH is Mallet, that is a topic modeling instrument. It allows you to see the topics in a document, and those topics are represented by a set of words. You'll also be able to create a column chart to see the prevalence of each of the recognized topics in the document.